Hello, our group will be doing our engineering design project on a toy carousel.
Our company name is STEM Shop, and this is our statement. STEM Shop strives to create fun and innovative toys that inspire kids to explore the curiosities in the STEM, science, technology, engineering, and mathematical field. Each of our products are carefully selected to not only be fun, but educational. Children are often impressionable at a young age, and it's a great opportunity to foster their drive to learn. STEM Shop takes pride in encouraging and motivating the minds of the future.
Here's our brainstorming process. We came up with 5 initial ideas: the magnetic fish, the scene box, marble stairs, Ferris wheel, and finally the carousel. Our concept selection process included evaluating them for their educational purpose, using our own selection process, and concluding with the final decision.
The educational purpose is one of the highest weighted on our criteria chart. It is vital for all our toys to be able to educate kids in one of the 4 different categories of STEM, technology, and mathematics. The concept selection process chart to evaluate each of the total points to see which one would result in the to continue.
So as we said, we're going to be looking at the different designs we selected from. First one was a magnetic. It's a customizable fish that was attracted to a magnetic fishing rod. Each of the parts of the fish had a magnetic end that allows it to rotate. And then children can learn about attractions and poles as they assemble.
The next design is a scene box. So it's a pre-built toy that lets you play the scene over and over again. Pieces that can be swapped with other sets, and it's one of 3 collectible sets.
Our third idea was marble stairs, where we have never-ending stairs, so the fun never ends. It's a very simple design and easy to manufacture, as it only consists of material, and it can be built with more stairs or extended to any size.
So for our next concept, we decided on looking at a Ferris wheel, which would feature a stylish gear-like trim to the wheel to sort of support our whole STEM theme. There would be a crank that would rotate the axle, and each cart rotates on its own separate axle. So children are able to look inside due to the clear plastic sides, and this will allow them to learn about the basic mechanics of a classic ride that they may like going on at the fair, and they're still having fun as well.
Our final choice was the carousel, which is education for children regarding the gears involved in turning it. And again, continues that never-ending fun for everyone. It could be bright and boldly colored for marketing. Influences the STEM brand to children if they learn the building process of putting a carousel together. And it's a very simple design that can incorporate other designs such as a box.
And this is the base 3D model made in SolidWorks. As you can see in the first picture, that it is created with the spokes going down into the base where the gears are held. In the second picture, where it is cut in half, you can see a plate in between the gear and the base of the carousel, which holds a plate that moves each spoke up and down, creating a cohesive up and down movement as the gear rotates. In the last picture shows a more detailed look at the inside workings of this carousel. This is a video of it in motion. As you can see, as the crank is turned, the whole thing moves around. Here's a few selected technical drawings, some multi-view drawings to show each selected parts in more detail.
Okay, and then now we'll be looking at the general monitoring process. So the first meeting was February 6th. This is just an initial meeting where we set up forms of education, assigned, discussed how we were going to create design. The next meeting was March 9th, where we viewed each of the designs and came up with the final decision of the carousel and assigned some project roles in terms of the report and SolidWorks. And the next meeting after that was March 23rd. This one was a meeting about more of the details, so such as uh, discussing the dimensions of the SolidWorks file and finalizing details about companies such as mission statements, final wording, our the name. And then the final meeting on March 25th was just finalizing details on our presentation and ensuring all the information was accurate and up to date.
This Gantt chart is a visual representation of our logbook. It displays the start and end times of each task.
So as we were finalizing the materials we would need and everything we would need in the setup, we had to establish what the cost of each material would be. So the main structure of the carousel itself, we were thinking of wood because it is both durable and it has a long shelf life. And we were thinking about 5 cubic meters would be enough. Sandpaper would be used to smoothen out any rough patches of the wood that we would find. We get 4 pieces for about $12.98 per piece. We would need a hot glue gun to hold all these spokes and other components together, which goes for about $6.99. And in order to polish up the final product, we would use a resin-based wood finishing, about 2 liters of it that go for $26.42 a liter.
After making our SolidWorks model, some potential changes we could make to our prototype are making it with cheaper material, targeting a wider demographic by finding an alternative to hot glue, and adding more functions. Future projects inspired by this design will encourage children to design a toy given some guidelines and overall create a greater depth of understanding in the STEM fields.
So, out of our 5 different ideas, namely magnetic fish, scene box, marble stairs, Ferris wheel, and carousel, we have chosen carousel as our final design concept. It does not have a very complex design, making it easy to manufacture, and has the ability to join different structures, for example, a music box. We believe that our final design is a brilliant and a striking idea for marketing. Our final design stands tall on our objective, that is, make fun and creative toys that motivate children to investigate their interest in STEM. We gratefully acknowledge our sincere thanks to our respected engineering design professor, Dr. James, for his remarkable, valuable guidance and supervision throughout the project work.
This is the end of our presentation. Thank you for listening.